I've been seeing this kit around in various places for a while. I thought it was time that I got one and put it together. You can see that it's a game because the rather ambitious title of Pixel Game Boy. But this is a game, so it's got a microcontroller in it. We'll have a look at what model that is in a moment. And it's got a couple of these quite nice displays. So this is what's this, an 8x8 LED dot matrix, and then there's some bits of hardware there. I can see a battery box and some buttons. There's not much to it really, so I don't think it'll take very long to put together. There's a cable. I can see a PCB here as well, some instructions, which is always welcome. And this I would guess to be some kind of Perspex case. I'll open that in a minute. Instructions. Oh, it's a nice thick PCB actually. You can see, you know, there's relatively little to fit here, so I have a bit of hardware. Oh, there's a resistor there, and a transistor, speaker. There's the chip which goes in a socket, and then the displays, buttons down the bottom. Oh yeah, and another display, so like a score display here with these. This triple 7 segment has to go in there. So we've got 4 AA battery box for 6 volts. We'll have to see if it runs on 5 volts, because then we could plug it into USB instead of having a battery box, couldn't we? Oh, that's a weird cable. Let's look at that. It's like a symmetrical USB cable. I've never seen anything like that before. A double-sided sticky pad. Oh, that's to stick the battery box to the PCB, I guess. So we've got the resistor, the 8550 transistor, NPN transistor that is, I think. There's a tiny ceramic capacitor. Where did that go? Oh yeah, under the chip. So you need a decoupling capacitor under the chip. There's also a 10 microfarad. Where's that? Oh, there. Yeah, so 2 capacitors, 10 microfarad, 25 volts. We have USB for the power. This goes up here. A beeper, sounder, and then 2, 3, 4, 5 switches and the buttons to go on them. Yeah, so pretty simple kit. And I'll warm up the soldering iron and we can get going. Okay, so I'm going to start assembling. Let's begin with the chip socket. Now I think I'm going to use this sort of hands-free thing today because I've got a lot of the item, you know, a lot of the elements on this board require a lot of pins to be done, so make sure I've got that the right way around. get a couple of corners anchored in. Okay, that's right, I think. I'll just do the rest of the pins. There you go, soldering not too bad there. So I think I might put these two little capacitor components inside the thing now. And leave enough room for them to lie flat, so I think I'll just put a bend in the leads here. Right, what next? I think I might start putting all of the stuff around the edge here. Start with this triple 7 segment. Peel off protector, but I think I'll leave that on for now until I've finished mounting components. So the next round is the USB. So that's quite nice because it's got some little kind of springy grips that are going to hold it in place. And you see when you fill these up with solder, this gives the connector a lot of strength. Those centre pins don't have any pads because of course it only really needs the power lines because it's a power socket. I didn't see that before, so there's the battery terminals wired in parallel, so you can power this either from USB or from that battery box. There's an on-off switch to go here. A bit difficult to hold this in place actually. Get one of the corners tacked on and then try and arrange it. Okay, pop the little button on. There's the piezo sounder, which it's got polarity. You see there's a plus and minus on there. Actually, I find these things very loud and high pitched. They're not really nice to listen to. A couple of components now, so there's the NPN transistor. The silk screen makes it quite easy to locate that correctly. There's only one resistor in this kit, so impossible to get wrong. So I think I might put the displays in next. Now, I think I understood from the instructions that they go this way round, so with the like the model name at the bottom. But I did actually take the precaution of buzzing the thing out using using a power supply and a resistor. So this is what I've figured out. So using the just kind of randomly touching the wires on the display. So look, I'll show you actually. So I've got a resistor there, so 1K I think. So what I was just doing is put the wire on one of these and then just kind of touch the pins and figure out where the various LEDs came on. So you've got what is it? So these rows, you've got 8 of these pins are rows, so they get connected to the negative, and then 8 of them are columns. So like if I put them, this is R8 here, and if I touch on the pins here you can see, so this is R8 on the right here. Well, that's what I called it anyway. So that's the way I checked the pins. And if you look at the board, I only saw this after I'd kind of buzzed it out, but you can see you've got R for row here, and so they use a different numbering convention from me, but you've got R for rows and L for columns, so I can see that that the instructions are right, and they actually have to go this way with the legend on the bottom. Mostly I've seen these displays used with a controller. So I've got one here. So this is like a 30mm side, and this is a 40mm side, so they're slightly different. But basically, you see a lot of these as kits, or you can buy them as modules from various vendors on eBay and so on. So this has got a driver chip, the Max 7219, so a Maxim chip, which makes these easier to use, because basically the Maxim chip drives the 8x8 grid, and then you just use about 4 pins here, so it's an SPI bus basically, and you've got data in here and a data out, which actually allows you to kind of daisy chain multiple modules. We'll probably do that in another video actually, but in this case the STC microcontroller is actually doing all of the rows and pins, so you have to get this thing the right way up. might as well get the other one in place at the same time. Do all the pins in one run. There's the legend, which goes down to the bottom. Okay, it's nice and flat, so I'll just dash through the rest of the pins there. There's one that looks a little bit dry there. Okay, so that just leaves the switches to go in place. I suppose that these are symmetrical. Yeah, they're symmetrical. Doesn't really matter which way around you mount them. I wonder why these have all got different numbers on them. Some of these are falling out of the holes. Let's just try and get one leg soldered in on each. Not the top's particularly wobbly. So just get a little bit of solder on each corner. Just try trying to make sure that they're all sat flat on the board before I kind of do all the pins. That looks pretty good, pretty flat. Feels good. And we've got these little yellow button caps. Oh, not that easy to push on actually. Okay, so we're just about done now. Let's push this chip in. So this STC microcontroller, this one's got no legend on it at all, but it is actually listed in the instructions. So there we go, STC 15F2K60S2, it says down here. So if you look that one up, you find that it's a 8051 core, but clocked quite fast compared with the old microcontrollers, and it's got 2K of RAM on board and communications ports. And quite interesting thing I might look at in another video, that a couple of these pins, I think it's the bottom right two, which I could solder some wires on there. That's actually a serial port, so you could connect a serial interface to there, which might be interesting to see if, you know, any text comes out of this while you're playing the game, or see if you can kind of send instructions in. So the chip has got an EEPROM on board, so I think you can reprogram it. So it might be possible to, obviously you can figure out from the circuit diagram which pins on the microcontroller go to the display here and the display here, and where the buttons are connected. So you might actually be able to reverse engineer how this game is constructed, and you could write some alternative code and blow it onto the chip. So yeah, in retrospect you probably want to put this in the socket first before you mount these displays, because you know, you can get a device that squeezes the pins of the IC. I've got one somewhere, but you wouldn't, I don't think you'd be able to use that here because the gap is quite tight, so you'd have to do that, you'd have to install that before the displays went in. There, I just managed to kind of squeeze one side of the chip and get those legs in place. Yeah, looks pretty good, I think. Yeah, all the pins are in the socket. So we can actually power it on and see if it works. Let's take these screen protectors off. Power bank here, you can plug into the USB socket. There we go. There we go, Tetris, fantastic. With some really terrible music. How do you rotate? Oh, there we go. Yeah. Good old Tetris. This display here looks very faint. I mean, we are in full daylight here, but can't really see very well what that says. 001, I think. So it's interesting because there's no current limiting resistors between the controller and the LEDs. So I don't know if the STC controller can set the maximum amount of current for the outputs. There we go. I think I'm increasingly losing this game now. Just stop. Oh, the power bank has switched off. That's a nuisance, isn't it? But there you go. So that works. So let's have a look at this case, because it has a case with it. I could put on the battery box as well. I'm not sure if I'm going to need the battery box, but all you do basically is solder the wires on here, red plus, black minus. You can run it off the 4AA batteries. So we've got some mounting hardware here. Oh, can't get the end of the bag open. So we've got some standoffs. 3 standoffs, that's a funny number. Some screws and nuts, some very long thin screws with matching nuts, and then some of this kind of acrylic with the protective paper So sometimes a bit of an effort to get this stuff off. So clear acrylic. This is obviously the top, isn't it? 'Cause is it, or is that where the battery box goes? Oh yeah, so that's the bottom piece, and then the top has got these holes for the buttons to poke through. So I'll just get on with peeling those and see if I can figure out how to assemble it. Alright, so I've fitted the 3 standoffs. They basically go to these 3 points here on the board, and then you got the 3 screws, so it's very obvious how to get the bottom panel on because there are 3 drilled holes here. And then obviously this side part here needs to have the cutout so you can get something into the USB port. And where's the other side? The other side plugs in there. And then this holds those in place. That's identical. Yeah, I think those are the same. So I'll plug those in place. And then finally the top plate obviously has the cutouts for the buttons, so you can't really go wrong there. And there we go. So the long thin screws mount through and hold all the panel in place, but that's quite good. Got a nice protective case. I did solder those wires on for the power. They're quite long actually, probably a bit too long. See if I can hide them away in there, and then that can go in there with the sticky pad. There's a little slot there for the wires to go down. That's quite nice. Alright, let me just finish jamming all that together. Alright, so finally assembled. So I put the sticky pad under there, and decided to have the battery box in. It's quite good with the sticky pad, quite solid. And I shortened the wires a little bit because there's too much wire there. So that's quite neat, isn't it? Let's rod it off the batteries. There we go, completed kit. That's quite a nice kit. I think it's, you know, well designed and pretty easy to put together. Recommended.